Exchange capacity is our next topic here. Exchange capacity. People oftentimes use the word cation exchange capacity. This one is looking at anion anions as well. So what we're testing in the soil basically is what is stuck to the soil colloid. People may have seen a picture in a, if they took a Master Gardener course or, read some sort of soil textbook. You got your sandy soil, right? You got your little sand particles. And basically, if you look down at it, scan electron microscope or something, you'll see there's these little bonding sites, these little electrons sticking out. So there may be a calcium attached right here, maybe a magnesium attached right here, maybe an iron or a copper, etc. But what we're testing when we take a soil test like this is this is called attached to the soil colloid. These are the elements that are readily available for the plant to take up. And that's what's being tested, is how many of them are there and what's the level and ratio in relationship to each other. So this is a sandy soil, this is a pure sand. And then you've got, the silty soil. There's much smaller particles and a lot more bonding sites where elements can be attached, etc. And then you get your clay soils, right? You get your pure clay, which has a lot more surface area and a lot more bonding sites. And basically, exchange capacity is telling you how many of these bonding sites where elements can be attached are there in your soil. Do you have a big capacity does your soil have a big capacity, lots of bonding sites to hold things? Or is it have a small capacity? I like to use a metaphor of a gas tank. I've never owned a motorcycle, I've ridden one a couple of times. But if you ever filled up a motorcycle gas tank, it's not very big. Yeah? Or if you've got a big F-350 pickup truck, you drop 30 gallons of gas in there and it's mostly full. Right? The big gas tank can hold a lot more. The small gas tank obviously can't hold that much. In the Midwest, they'll say that a field with a cation exchange capacity of 5 may have a yield potential of 50 bushels to the acre. Because the soil can't hold that many nutrients, it can't produce that much crop. An exchange capacity of 10 maybe has a yield capacity of 100 bushels per acre, 15, 150, etc. Right? I'm making these numbers up, but it's something like that. The larger the exchange capacity, the more your soil can hold nutrients, the more it can feed the plant, and the larger the yield potential is. So these are all pretty much set. Your soil is what your soil is. It's either a sandy soil or a sandy loam or a clay loam or whatever it is. The X factor here is organic matter. Whether it's humus or it's biochar or it's just old dead plant material, organic matter is has this nice fractal kind of structure, ideally, and it's got lots and lots and lots of bonding sites and can hold a lot. So generally, the more organic matter you've got in your soil, the higher your exchange capacity is. That's the thing you can work with over time. You can't really dramatically change the nature of your soil unless you're dealing with like a raised bed. So that's exchange capacity simply conveyed. I don't think we need to spend much time on it. Just so you understand the term, generally between 8 and 12 is considered to be normal, whatever normal means. So if you've got an exchange capacity of 5, that'll probably be a pretty sandy soil. If you've got an exchange capacity of 18 or 20, you've probably been adding a lot of compost, I would guess. People who have exchange capacity that high generally don't have it around here with our weathered clays. They don't even, out west you can get an exchange capacity of 20 or 25 on a clay soil because the clays haven't been weathered so much, hasn't been had so much rain for the past 10,000 years.